All right, hello and welcome. In this video, we're going to look at how to calculate out this output voltage for the RC integrator circuit we're given. In this case, the voltage out is going to be the same as the voltage across this capacitor. And so that's what we are going to shoot at, is getting the voltage up across that capacitor. And we use this equation down here to figure that out, which just basically takes the voltage drop across the resistor and compares it to 1 over the time constant here. And that's going to allow us to calculate this out through our integral. So let's do that. We'll say we have 1 over our RC time constant, which is 27,000 multiplied by 1.6 microfarads. This one's in ohms. And then we have our integral equation, integral of whatever time value to 0, and our voltage across the resistor in terms of time, which was given as 16e to the negative 400t, and that 400t is going to be our frequency, and that's volts, and then we got our dt at the end. The dt is going to be resolved once we resolve the integral here, and so that is our goal. So we'll type this in. We'll say, let's write it out one more time here, because we need to pull out our integral to calculate. So we currently have 1 over 27,000 times 1.6 microfarads. And when we pull out our derivatives here for our integral, we're going to say 16 goes out front and the negative 400 goes out front, but they have a relationship together. So our magnitudes, which is this base number here, the constant, will multiply our current value that we have on this side by 16, which is our constant, divided by our exponent, which is negative 400. All right, so this is the only difference between this one and the differentiator for that integral versus derivative. And then the rest of this is going to have the e to the negative 400t, and it will still be in volts. Okay, so in this case, we're actually going to pull out this negative, and we're going to write it in terms of a positive number, which is 1 minus e to the negative 400t, and so that's just going to be resolved out. So if we calculate this out and we get a negative output, it's going to be taken out, and we're going to plug it in using this back end. So we'll rewrite it afterwards, as we're saying. So 1 divided by 2700 multiplied by 1.6 times 10 to the negative, micro is 6, and then we'll multiply that number by 16 divided by negative 400. We get this number here, so we'll write that in. We'll say that we have a negative 0.926 e to the negative 400t volts. And to get rid of this negative out front, we'll just write 0.926. And then in parentheses here, we'll say 1 minus e negative 400t volts. Right, and so now we match into the equation that they want us to put it in. And so we'll type our answer in down here as a positive 0.926. And from here, we'll just plug in our time interval. And we know that the time was given to us here. So we'll take our 0.926, open parenthesis, 1 minus e to the negative 400. And in this t value here, we're going to put in our milliseconds value in terms of seconds. So 0.005 seconds. All right, and we'll close that off. And this is how we're going to type it into our calculator here. So 0.926. And we'll open parenthesis, 1 minus. In the function side, you have this e to the x value, so we'll put e to the x, and in that x location, we'll say minus 400, open parenthesis, 0.005. Right, and that gives us a positive output there. That's what we're looking for. And our answer is going to be 0.8. And we'll type that in down here, 0.8, and we'll check our output. There we go. Okay, let us know if you have any questions.